Okay, well, hopefully this exercise is going to help you bring a lot of things together. And we will have a test next week. I'll be giving you a bunch of sample problems on Thursday. Test will be in the testing center. It's designed to last 45 minutes, an hour, fairly short. But some people take longer and there's no time limit. Okay, so if you do take longer, as long as you get there in time before the testing center closes, nothing interferes, you'll have as much time as you need. And this is one of the things I'm going to ask you to do. It's sort of the primary thing, because this really covers a whole lot of chapter 1. Now let's see if the camera's going to choose to focus on the board. It's kind of looking at me right now. Okay. So, first of all, most of you did type 3 grid. Not everybody did it right. Got your 2 center lines, halfway from the right edge to the center, halfway from there to the center, halfway from the left edge to the center, halfway from there to the center. Then halfway from the top to the middle, from the top to the center line, halfway from there to the center line. This distance will be half of this distance. Some people are drawing 3 equally spaced lines here, and you get a distorted graph, and you're not going to get good estimates, and you're not going to get the right shape of the graph. Anyhow, I'm not going to say much more about that, because we've done this repeatedly. We haven't done that many type 3s, so I guess it's good that we did a type 3. Now, let's say that my numbers were 4, 7, and 9. Okay, well, where's the red dot on a type 3 graph? I keep getting faked out. I've got the blue chalk on the chalk holder with the red, and I don't even know where the red has gone to hide, but I'll use this one. There's a red dot. Red dot is at 4, 7. It tells us that this line is x equals 4. This line is y equals 7. 4 by 4 grid, meaning it's 2 units from here to here. So this is x equals 6. 2 units here. This is x equals 2. 2 units above y equals 7 is y equals 9. 2 units below is y equals 5. We can label the rest of the lines. This is going to be x equals 3. This is going to be x equals 5. This one's going to be x equals 3.5. This is going to be x equals 4.5. And then this is y equals 8, y equals 7.5, y equals 6, y equals 6.5. There's a grid. The rule is, for the reciprocal function, start to left edge on the line just below center. There's a point. Right 1, down 1, right 1, down 1. And you could draw more lines halfway to the center from here, and then halfway from there, and they'd be getting real close together. Each time you go twice as far below the center line as you were before. And that's worth knowing. Read the transcript if you don't want to listen to it. Or if you totally understand it, that's fine. And then over here, start the right edge just above center, left 1, up 1, left 1, up 1. And there's your reciprocal graph. Okay. Now we want to estimate the y value for x equals this value plus 1.4. So we draw a vertical line. X equals 4, add 1.4, we get 5.4. 5 is here, 6 is here, halfway here, that'd be 5.5. 5.4 is just a little to the left of the halfway. X equals 4 plus 1.4 equals 5.4. I would write all that out so that you're documenting everything you do. Okay? Yeah, you're just reminding yourself that that was instruction. Whatever this value was, you add 1.4 and you get 5. Okay? And then you estimate your Y. So you draw a line here. I drew it a little too high, but I'll just go with it. It looks like if that's 7.5 and that's 8, this is Y equals 7.7. Okay, so if this graph is f of x, we haven't got a formula yet. I was going to give you a formula and ask you to compare it with your estimates, but very few people actually got estimates. Okay, you got to know how to do that. We've done it several times. Make sure you know how to do it. You know, and let's make sure. Oh man, the stupid camera. It was a little blurry, but you could tell what was going on. Okay. So didn't necessarily see all the labeling and details, but there it is. And that's something you just automatically know how to do for any of these 3 graphs. Okay. You just have to be there with that next week. And many of you did, about half the class got good graphs, maybe more than that. Sometimes the grids weren't so hot. Make sure you know how to do the grids. Make sure you know the rules for the functions. Okay. So anyhow, you can say then that f of 5.4 is approximately equal to 7.7. That's what this estimate tells us. Now we have another estimate to make. We want to estimate x. We want to estimate the solution of y equals b plus 3. Okay? So this comes from estimate f of 4 plus 1.4. We want to now estimate the solution of y equals, it was b plus 3. And that's really kind of stupid because I was intending the squaring function so you could do b plus 3. Okay? If you did the reciprocal function, you couldn't do it. And since I told you to do a type 3 graph, if you did the reciprocal function, that's pretty natural. No prejudice there, but I'm going to have to change the rule. Y equals, I'll say b plus 1.2. In this case, I'm going to actually change it for the reciprocal function to a b minus 1.2. Okay. Now that's going to be y equals 2.8. Okay. Because b is your x equals 4, you go 1.2 to the left. So what we do is y equals 2.8. Okay. Now, that would have been right, but it should be 7 minus 1.2, which would be 5.8. Okay, sorry for the confusion. And let me just write out the arithmetic of that. B, as you know, is the second coordinate of the red dot. So in following my instructions, if I'd have said B minus 1.2 instead of B plus 3, B plus 3 would work on either of the other two rests, but not on this one. Okay. Now, y equals 5.8. Where's y equals 5.8? Well, here's 5 and here's 6. It's much closer to 6 than 5. 4 times as close to 6 as it is to 5. So we'll just say, okay, y equals 5.8, approximately. Then we find the graph point, and our solution is x equals what? It's between 3 and 4, closer to 3 than it is to 4. Looks like it's about a quarter of the way. Usually we don't try to estimate to the 100th, but that looks so close to a quarter of the way, I'm going to say 3.25. Fair enough? Now, all that should be familiar. I mean, the homework asks you to do exactly the same thing. Okay? Had a graph and asked you to estimate f of 3 and had to estimate f of x equals -4 or whatever. And almost everybody that did the homework got that. Okay? Homework looked pretty good. So just doing the same thing we do in homework, except you're drawing your own graph. Because we're trying to anticipate what happens in the rest of this chapter and throughout the course. Okay. Well, there it is. Now, the other thing I was going to do is, and I'm going to introduce this now. Okay. Now, the toolkit reciprocal function I've defined for this class is being in a 4x4 rectangle with the red dot at the origin, right? Well, we still have a 4x4 rectangle, so it's undistorted. The shape is the same as it would be if this was the origin, but it has been moved. Okay. The units horizontally, that means in the x direction. 7 units vertically. That makes sense? Because the red dot for the toolkit function is at the origin for type 3 graphs, for the reciprocal function. If the red dot is now at the point 4, 7, that means we've moved it over from x equals 0 to x equals 4. Okay. And if the origin's down here, we've moved it from here to here, that's 4 units. And then we move it up 7 units. So it's like your XY coordinate system has the origin right here. We move over 4 units and up 7, and now we've got this. Okay. I'm going to say y equals f of x. And now we want to get the function undistorted. Now remember, the second part of this was supposed to be you're going to do an 8x4 rectangle and label it. That would have been distorted. Or if I make the rectangle fatter or thinner, I'm going to keep it always at 4 units for now. So I'm not going to distort the rectangle in the horizontal direction, but we'll distort it in the vertical direction. Sometimes we'll even turn it upside down. We'll see that, but not today. Toolkit reciprocal shape is y equals f of x equals 1 over x. And now I've got okay. I didn't use the f of x notation on the directions. I'm going to change the f here and the f here. I think those are the only f's I have. I'm going to change those to g. That doesn't confuse you because we haven't really used the function notation yet. Because I want f of x to be this function, not this function. Okay? This function is g of x. Now, anybody want to speculate on what the equation for the function g of x would be? Give you a chance in a minute. Think about it. Idea? I kind of told you, but in the middle of the class, you're kind of always up to your behind in alligators, and you forget that the objective is to drain the swamp. Analogy being some of the side things I say usually go by, but if you look back at the videos, you can see. Of course, you can't spend your whole life looking at the videos. You can scan the transcripts, which are pretty good, but I haven't had a chance to edit them. Okay, y equals g of x. Well, I'm going to tell you what it is. It's f of x minus h plus k. Okay, now, can you show me with your fingers what the value of h would be for this function? Yeah, 4. I've used h and k for the coordinates of the red dot repeatedly. If you haven't noticed, again, you focus on something else I'm saying, and you might not have picked that up, but that's the standard notation, okay? So I can say here that h equals 4 because of the horizontal shift of 4 units, k equals 7 because of the vertical shift. Now it's f of x minus h plus k. Can you write down on your paper? Now, remember f of x is 1 over x, right? What's f of x minus h? What's f of x minus h plus k? See how many of you can write that down. Okay, so the success rate on this question was not very good, but let's make it good, okay? And I have explained this before, but I don't remember if it's in this class or the support class. I don't know. Um, but if f of x is 1 over x, what's f of x minus h? Well, x has become x minus h, hasn't it? So if x becomes x minus h, we have 1 over x minus h. Now, some people wrote 1 over x minus h, but that's not what you get if you replace x by x minus h, is it? Okay, so be sure you know how to use function notation. You're just replacing x with whatever is in parentheses. And you're not going to get good results on this problem unless you really know the function notation. Now, everybody did well with the function notation on the homework, but there wasn't that much of it with symbols. It's mostly with numbers. So there's some reason you might not understand with the symbols, but this is the way it's been explained, so that's the way it is. Well, then what's f of x minus h plus k? Well, f of x minus h is 1 over x minus h. So whatever that is, you're adding k. So you just do plus k. Okay. So in this case, it's 1 over x minus 4 plus 7. Now I think I just went off of the edge of the board, but there we are. So on a table problem, I will ask you, what's the formula for this function? It's always f of x minus h plus k for an undistorted graph. If you don't have that in your notes, look at it every morning, first thing when you wake up, every night, last thing before you go to bed. Well, you might have better things to do first thing you get up. And you might not want to pollute your brain with this while you're trying to sleep. Okay, so, but you get the idea, right? Okay. Now for this function, it's poorly written, kind of crowded. It just says G of 5.4, the thing we approximated as 7.7. Turn this up. Okay, G of 5.4 is 1 over 5.4 minus 4 plus 7. which is 1 over 1.4 plus 7. And I didn't know what this is going to turn out to be. I didn't predict it. I didn't know people were going to do the reciprocal function, even though that kind of goes with the instructions I gave ambiguously. You can do the reciprocal of 1.4 and find that it's 0.7. What was my estimate from the graph? Just from drawing that line, it was 7.7. Did I draw an extraordinarily accurate graph? No, it was fairly accurate, but it wasn't extraordinarily accurate, but I still nailed it. Okay. Now that's a fairly easy part of the curve to nail because it's close to horizontal. There's not that much rate of change as you go up or down, or, you know, as X goes back and forth, this doesn't go up and down very fast. Over here, it goes up and down real fast, so I wouldn't have been as close. I wouldn't have been likely to be nearly as close. Okay, do you understand what I'm saying? Because I want you to be able to do all this. Okay. And I want you to get it together for a test next week. The other is solution of y equals 5.8. Okay. Now I don't have a lot of room over here. So I'm gonna insert it over here in bright yellow. Y equals 5.8. Well, y is g of x, which is 1 over x minus 4 plus 7, right? Since y is 1 over x minus 4 plus 7, your equation is 1 over x minus 4 plus 7. Now, I'm not actually going to solve this equation, but I'll tell you what you do is you multiply both sides by x minus 4. That gets rid of all denominators, okay? And then it's just a simple linear equation. And you should be able to solve it. But what we're going to do is we're just going to I'm not going to ask you to solve a lot of equations on the test, but I want you to verify the estimate x approximately equals, what did I say it was? 3.25. This is on a pretty steep part of the graph, so I'm not expecting to nail it as well as I accidentally nailed this one. Okay, 3.25 minus 4 is negative 0.75. Then you got the plus 7, which is very close to negative 1.33 plus 7, and that's 5.67. You can verify the numbers. Okay. So it was supposed to come out 5.8. It came out 5.67. If you round that up to the nearest tenth, it comes out 5.7, which isn't bad for 5.8. Okay. Make sense? That's a process you're going to need to be able to do for any of these functions. Okay. And that's the process. So you need to review that. You need to watch that video. You need to write some of these out. And, you know, I'm going to assign you to do this exercise, both for the squaring and for the exponential function, and send me a copy. Okay? Do that. I'll give you some points. using the numbers I gave you. Remember what they were? Uh, I don't want everybody using the same numbers because some people might just use somebody else's. Okay. Don't want you to do that. I want you to understand the process that I went through here. Okay, now the difference in the process, if you do the squaring function or the exponential function, still rolling, aren't we? Okay. What is y equals f of x minus h plus k for the toolkit squaring function? And what is it for the toolkit exponential function? Down on your paper, see how many of you can write it down correctly. I'm going to give you just a little help. You should know the equations of these functions because you had it on the homework last night. Okay. You didn't have this one, but we've used it a number of times and you should be used to it by now. And the camera's all blurry, so I'm going to have to fix that. And there's a question. See if you can write that out quickly. Really, really, really need to understand what I mean by substitution. Watch again. What did I do here? Said f of x is 1 over x. Now, if I write f of x minus h, how am I going to get f of x minus h from this? I'm going to replace x by x minus h. So I'm going to put an x minus h in here instead of x, which is what I've done. Well, if I replace one x by x minus h, I've got to replace them all. So I replace this x also by x minus h so that this becomes this. Okay? It's simple replacement. You replace all the x's in this expression with x minus h's. Or whatever's in parentheses. Okay? And of course, then what you want is f of x minus h plus k. Well, it's easy to tack a plus k on it. It doesn't go down here. A 1 over x doesn't go here. Okay? It's literal, exact substitution. Okay? So let's see what we get. It didn't read your email, they didn't get the homework done. Okay? Most of you did, and most of them looked pretty good. If you didn't get the homework done, since you weren't used to looking at the open math assignments last week, I'll cut you a little slack on that. And you can go to the half credit page and do it, then email me and I'll give you full credit for whatever you get. Okay? So that's just an amnesty, but it's got to be done before class next time, along with the assignment for next, which I haven't had a lot of time to talk about. It's just so important. Okay. You got f of x equals x squared. So what is f of x minus h? How do you get from f of x to f of x minus h? Well, x is being squared, so that makes sense. Okay, because y'all picking it up well as a group. Some of you are, but run at about 30%. Okay, not seeing the substitution aspect. And we've been talking about that, a couple times last week. That's how it's done. So if you don't have that down, make sure that by the end of today you do. Because if you have it by the end of the day, it's going to be fine. And we don't read anything into this. We don't put a square on this x because there's a square on this x. This x has nothing to do with this x. Okay? The x here is just the formula if you happen to have x in the parentheses. If you happen to have x minus h in the parentheses, then you got to have x minus h squared, not x squared minus h or x minus h squared. Not, so a lot of this. So the f of x minus h plus k equals x minus h quantity squared plus k. For the toolkit exponential function, write out the definition of the function. Don't have the definition of function 6 pages over in your notebook or chiseled into the stone wall of your wine cellar. I don't know. Okay. Understand that you want it right there. So when you try to do f of x minus h, you can directly see f of x. You don't have to look over there. You don't have to look over there. You don't have to pull it out of a big paragraph. It's right there in front of you. So we have f of x minus h. Then how do we get f of x minus h from f of x? We change x to x minus h. We change this x to x minus h. So we get 2 to the x minus h. Then f of x minus h plus k equals 2 to the x minus h plus k. K doesn't go up here in the exponent. It's not in the exponent in this expression. Okay? And the fact that x minus h goes into the exponent doesn't mean that k goes into the exponent. All right? Okay. So try to get this down because you're going to need it. Because that's a language that we're going to use in the whole course. Okay? It's simple substitution. All right. I can't emphasize that strongly enough. I can't tell you how important it is. And once you get used to it, it's natural. Like anything else, it's unfamiliar. You try to read things into it, you get things mixed up. get over that now. Okay. Okay, I'm not sure where the video was stopped, interrupted, but I think it might have been even after or before I put these questions up here. Now I've got the solutions, but the question is, what's y equals f of x minus h plus k for the toolkit squaring function and for the toolkit exponential function? The point that I am trying to make very clearly is that just do what you do for this. And this was up there when y'all were working on it. F of x equals 1 over x. So what's f of x minus h? Well, to get f of x minus h, you take this entire definition and replace all the x's by x minus h. And what do you get? Well, this x is replaced by x minus h. Replace this x by x minus h. This is what you get. You don't get 1 over x minus h. You don't do anything with x except with x minus h, except put it literally wherever you see an x. And then f of x minus h plus k, and never wrote the plus k here, so that might confuse somebody. Well, now that's all messed up. F of x minus h plus k is whatever this is, and then you put a plus k. You don't put a plus k in the denominator. You don't put a k in front of x. You put plus k because it's this here plus k, in this case plus 7, okay? But here's the form. Now, doing that for the x squared function and the exponential function, what do we get? The toolkit squaring function, I've emphasized, write down f of x equals x squared. Write down the formula for the function that you're going to substitute into. If f of x equals x squared, then to get f of x minus h, which is one of the things we need up here, all the x's get replaced by x minus h's, not by x squared minus h, and so forth. Okay? You don't read the squaring inside of something that it's not inside of in the first place. Okay? You literally replace x by x minus h. And then if you want, of course, f of x minus h plus k, f of x minus h is this, and then you put on a plus k. The toolkit exponential function, if all the x's are replaced by x minus h, you get f of x minus h. And on this side, you get 2 to the x minus h. This x is replaced by x minus h, and so is this one. And if there are more x's in the expression, you replace them all. So that f of x minus h plus k is 2 to the x minus h plus k. And then the graphs of these functions, to give you a little extra, f of x minus h plus k is basic toolkit graph. Shifted h units in the x direction, k units in the y direction, so that the red dot ends up at hk. The red dot is at the origin for any toolkit graph. And it moves h units in the x direction, k units in the y direction. Now, if h is negative, it'll move to the left. If k is negative, it'll move down. Introduction to domain and range. The domain is a set of all x values in a curve in whatever window you're graphing. The range is a set of all y values. For the toolkit, basic toolkit, reciprocal function, I haven't done the whole grid and everything, but everybody has seen that. We've used it in class, so here it is again. You go from -2, x equals -2 to 2, y from -2 to 2, because the red dot is in the middle and it's a 4x4 grid. And you know that you start on a line right below the center line. That's the line y equals -1/2 if you do the type 3 grid. And you go over 1, down 1, over 1, down 1, and end up at the bottom edge where x equals -1/2, and so forth. You know how to construct that graph. So for that graph, the domain is what? It's in blue. All the x values from -2 to -1/2, and all the x values from 1/2 to 2. So this is the interval -2, -1/2. This is the interval 1/2, 2. And that's how we write it. It's this interval union with this interval. Union means if x is in this, then you're in the domain. If x is here, you're in the domain. Can't be both places at once. It's either here or here. If it isn't here or here, it's not in the domain. Why? Because there's nothing between this point and this point. There are no points on the curve between x equals -1/2 and x equals +1/2. The range is similarly the set of all y values, and I could show you where the range is. It's all the y values between -2 and -1/2, union with all the y values from 1/2, -1/2 to 1/2. Restrictions on the domain, if you have formulas. Example, y equals square root of 3x plus 5. That doesn't work if I'm off screen here. Okay, here's your domain for this function. Here's how you write it out. Open Math will show you the interval notation. Okay, and I'm still not on screen with there. Or am I? Yeah, I am. No, I'm not. Okay. So if you have y equals square root of 3x plus 5, 3x plus 5 can't be negative because you can't do the square root of a negative. Okay, so 3x plus 5 has to be greater than or equal to 0. You solve 3x plus 5 greater than or equal to 0, you get x greater than or equal to -5/3. I've kind of got this, all this goes together. This is solved by subtracting 5 from both sides and dividing both sides by 3, and this is what you get. Another way you restrict the domain is if the denominator could be 0. Its division by 0 is undefined, it's forbidden, doesn't make any sense. So if you have 1 over x plus 4 or anything over x plus 4, x plus 4 cannot be equal to 0. So x plus 4 equals 0 is forbidden. And x plus 4 equals 0, well, it's easily solved. X is -4. So whatever you have in the denominator, set it equal to 0 and forbid that value. If you have an expression under a square root sign, set that expression greater than or equal to 0 and solve it, and then you have the values that can work. Okay, the domain.